So what we're going to talk about today is I'll just tell you a bit about myself, and then I'll go over, what is polars, and then I will discuss the 3 reasons why I switched from pandas to polars. And there's 3 reasons. There's the list namespace, there's scan parquet and sync parquet, and data-oriented programming. Then there'll be a brief demo, and I'll talk about what next. So first, a little bit about me. So my name is Ben. I'm a data scientist and data entrepreneur with backgrounds in optics and medical tech. So I grew up in Boston, and I did my university, my degrees at University of Rochester, where I have a bachelor's of science in optics. And towards the end of my degree, I was kind of liking data science stuff, and there was a new program starting, a new master's in data science program starting. So I just decided to stick around for another year and get a master's in data science. And then I worked at this company, Systems and Technology Research, for a couple of years in government defense research contracting. And I took like a pivot. I went to Yesware, which is a startup company in Boston, which does it developed like a sales email sales tool. And I was actually as a full stack web developer there. Even back then, I was really interested in like the full stack, not just data science, but how does data science and machine learning fit into the whole thing. I was laid off shortly thereafter, I think after 2 or 3 months, because startups be like that sometimes. And after that, I kind of took a year to travel a little bit and do some freelancing. And that's really where I got started with working on Upwork. I did, I think, a couple of freelancing contracts there a little bit. The focus was more on like, exploration, travel, and all this stuff. And then after that, I moved to Delivery Hero, which is a German company. I live in Germany, I live in Berlin, Germany, just to kind of continue the international exploration phase of my life. And then I've been working there for about 3 years. And in the past 6 months, partially because of inspiration from Shaw and his freelancing stuff, I started doing some freelancing on Upwork, writing some stuff on Medium. And at this point, I speak, I think, 4.5 languages. I'm learning Hebrew now. My wife is Israeli. But yes, I have 5 years of data experience, speaking over 4 languages, and my blog on Medium has over 15,000 views at this point. And in my first year of freelancing, it's been 350 hours plus over just 2 engagements. And yeah, I'm looking to grow that. So thanks for the introduction, Shaw. And yeah, so next, what's polars? So polars is the new hot thing in data science. It is, oh, I should be full screen. That's much better, isn't it? What's polars? Polars is a blazingly fast data frames library implemented in Rust using the Apache Arrow columnar format as the memory model. So Rust is this programming language that's very close to the system level of computers. So it's kind of like you get C++ performance. And it's using the Apache Arrow columnar format, which is also used by things like Parquet files, right? It's this kind of standard, it's a standard memory model that's used across many things. It's used and it's managed by Apache. So it's optimized for columnar-based data, right? So if you want to query a data file or a data table, in the way that we do normally with data today, where you want to subset some columns, or you want to filter or partition by some attributes of some columns, it's a very efficient way to do that. So polars follows this same memory model, the same popular, pedagogical memory model. So just it's easy to start with when we're talking about polars versus pandas. It's easy to say what polars is not, right? Polars is not just a framework for alleviating the single-threaded nature of pandas, right? You have Dask, you have Modin, you have Ray that do this, right? They try to replace sort of the infrastructure underneath Pandas or other things. But Polars it's a full makeover of the Python data frame, and it's founded on Apache Arrow. It has its own query optimization engine. And we'll see that query optimization engine in action a little bit in the demo. So now that we know what Polars is, you know, what are what makes it so good? Why are the 3 reasons that I switched from Pandas to Polars? Right, the first reason is the list namespace. So just checking for questions. Okay, all good. The first reason is the list namespace, right? So if you're a data scientist and you have used Pandas for, you know, even, I don't know, 10, 15 hours, you probably know that Pandas doesn't explicitly support a list data type column. Rather, it uses an ambiguous object data type, and the list columns must be processed using the string namespace. Right, so if you look at this code example here, we say that, you know, we have this family data frame, right? Family df equals pd.dataframe, right? That's Pandas. PD is the idiomatic name for Pandas. pd.dataframe, last name, right? We create the last name of some families, the members of some of those families, and the city of residence of those families, right? So for the last name, it says Johnson, Jackson, and Smithson. The members of each family, right? We have John Johnson, Ron Johnson, and Con Johnson, etc. And then the city of residence, we have Boston, New York City, and Dallas, right? So if we want to access, let's say we want to create the family leader for each, you know, row in our data frame, we have to say family df members dot string, and then you index with this bracket notation 0. And what's the result of this, right? Let's look. Right, it says, right, we have our last name column, Johnson, Jackson, Smithson. We have the members column, which is this list data type. And then we have the city of residence, which we created. And then we have this computed column, family leader, which is John, Jack, and Smith, right? The 0th element of each member list, right? So in order to do that, we had to use the string, you know, the string namespace, which is annoying, right? And here on the right, we can see data scientists on Stack Overflow discovering for the first time just how to do this, right? But with Polars, you know, you have a dedicated list namespace, right? So the code for creating this data frame is very similar with Polars, right? We create the last name column, the members column, the city of residence column, and then we create, you know, df equals df dot with columns, right? This is the Polars syntax for adding a new column, right? pl dot call members dot list dot get 0. Right? And then you alias it, right? You give it a name as family leader and you show it, right? So we see the same thing. Last name, the result is the exact same as above. The only difference is that we just used a more explicit syntax to do so. So more about Polars data types, right? Polar data types are all internally consistent. They're based on Arrow, and they include more than just .list, obviously, right? And you can see some of them in this table below. And by the way, guys, just as a short note about this presentation, I think that the Polars version is still like 0 dot something, which means that technically version 1 has not been released yet. And with that, some of these things may change. So for example, the .list used to actually be .array, .r or ARR, which has changed. So anyway, it's still new. So anyway, just as a reference, but you know, you can see you have integers, unsigned integers, floats, booleans, strings, binaries. You have the list, which we're just talking about, a struct, which is kind of like a dict data type. You have all these things, right? All these data types that you could want. You know, if you compare with Pandas, right? Pandas uses a mix of data types that are not internally consistent, right? It takes some data types from NumPy, it takes some data types from Python, and now Pandas 2.0.0 has Arrow, right? So just as like a complicated point, a nan, like not a number in Pandas, can be represented either as a NumPy nan, like a Pandas nan, or I think it can be a Python null. And I don't know if it can also be an Arrow null, but it can be all these things, right? Which can really give you headaches when you want to use functions like isNan or isNull. right? Polars doesn't have any of that. So it's a lot more just clean internally when it comes to the data types. But why is it such a big deal, right? In this, right, Polars is new and it's clean and all this stuff, but in comparison, right, the Pandas API has become a little bit bloated, right? So we just saw how the Pandas API required that we use the string namespace for handling a list data type. But that's not it, right? The API has become bloated, and you have this thing where the opposite problem, where some things can actually be done by multiple functions, and some functions can do multiple things, right? So if you take this common notation in Pandas of the open close bracket, right, it can do three distinct things. It can retrieve a column of a data frame, it can perform a row-based Boolean mask on the data frame, and it can retrieve a slice of a data frame by index, right? So if you look at this code on the right, here we're just creating a simple Pandas data frame. A and B are the columns, 1, 1, 1, 4, 5, 6. And then we have these three different indexers, right? We have a column name indexer, a Boolean mask indexer, right, where we say, where the column B is equal to 5, and then we have a slice indexer. And then for each one of these indexers, we get a totally different result, right? So these are three distinct operations done by the same syntax, which is crazy. That can make it really hard for people to onboard, and it can also make it really hard to debug and even read code. But in Polars, it's not like that, right? You can do everything you want to, and there's almost always one way to do it, and it makes for an easy learning curve. So that's that. The next reason why I switched from Pandas to Polars is the scan parquet and sync parquet functions. Gonna have a quick sip of water. Let me sink the water. Okay, never mind. Okay, so sync parquet and scan parquet. Pandas is slow, right? In case you didn't realize, right? So in a 2017 blog post titled Apache Arrow and the 10 Things I Hate About Pandas, the creator of Pandas himself discussed, among many things, the memory footprint of Pandas. He said, my rule of thumb for Pandas is that you should have 5 to 10 times as much RAM as the size of your data set, right? And this was in 2017, right? That's over 5 years ago. So this problem has been around. Polars has emerged from the muck like a lotus. In Pandas, you have everything happening in memory, but Polars, however, has a lazy API, and with that, you can process larger than memory data frames. When I say lazy API, it means that it's all your operations are computed at the time that you call a collect or the query is run. Well, anyway, that's a bit. We'll get into that in the demo, but right. Talking about the eager and the lazy API, right? Polars has two APIs, eager and lazy, and with that you have this. In the lazy API, you have this scan and sync parquet, right? So similar to Spark, another data processing library, Polars offers two APIs. It offers an eager API and a lazy API. But the eager API, like Pandas, it runs everything in memory, right? You write a line of code, it runs that line of code, done. The lazy API, however, it does everything only when it's explicitly asked for a response, right? So with a .collect statement, similar to something like Spark. But when using the lazy API, Polars uses its query optimization engine to compute results as efficiently as possible. Again, we'll see that some more in the demo, but that means that it figures out the actual best order of operations to do things in, right? So if we look to the right, just some of these examples, right, of the syntax, right? You can create a data frame with the eager API using data frame, or with the lazy API, you can say lazy frame. If you want to input a CSV, it's read CSV and scan CSV, read parquet and scan parquet, write parquet and sync parquet, right? So the whole library, the whole API is really built for this kind of duality, right? There's like a mirror of every function. And you can see that just below, right? We have the eager DF creation and the lazy DF creation. They're basically the same thing, just replacing data frame with lazy frame. And the big thing is that by using scan parquet, lazy frame, and sync target, you can process large in-memory data sets. And you can read about this a bit more. This is a hyperlink if you're interested to follow along. That talks about it's from the Polars documentation that talks about streaming data, which is it's really powerful stuff. And so I'm talking about speed here, right? But just to say, for me, when it came to switching from Pandas to Polars, I came because I was interested in the speed, but what really got me is the syntax and how pleasant the API is to work with. And that's what this talk is mostly about. If you want to learn more about the performance comparison between Pandas and Polars, it's a bit beyond the scope of this presentation, but there's numerous articles online that compare Polars to Pandas. The different versions of Pandas, because there's Pandas, the old version, then there's the new Pandas 2.0, which has backed by NumPy and backed by Arrow, all of which still show Polars to be the fastest. So there's just some sources here you can follow up if you're interested. Anyway, so the last reason that I switched from Pandas to Polars is because of this concept of data-oriented programming, right? So with data frames, most of what we want to do is run queries or transformations on data, right? We want to add columns, we want to pivot along two variables, we want to aggregate, group by, all that stuff, like we just saw with that sort of a family data frame at the beginning. So even though that's the case, the Pandas API doesn't really lend itself to that use case, right? It often requires multiple assignment operations for one query, right? Which Polars doesn't do. So, right, if you look at this code comparison below, right? If we want to know, let's say we're given a data set of people and ages, right? And we want to know how many people are of each decade, right? So we're going to do a query. We want to show the comparison. So on the left, we have the Pandas code, right? We create our data frame. Data frame is df equals pd.dataframe. Here are the names, here are the ages. And then we create a decade column, which is df of age divided by 10, or just casting it to the nearest 10 value, or the nearest decade. And then we do the group by, right? So we have to do 3 assignment operations, right? There's 3 equal signs here. There's the data frame creation. Oh, whoops, sorry. There's the data frame creation. Then there's the decade column creation. Then there's the decade counts result, right? So there's 3 equal signs. But on the right, if we want to use Polars, then we can do it all in one query, right? 1 equal sign, 1 assignment operation, right? So we create the data frame, we add the columns using the Polar syntax of with columns, right? Doing the same casting to the closest decade. We group by decade, we aggregate, and then we print, right? So it's just clean. And it's similar to Spark, it's more similar to SQL. Pandas really deviates on this. Polars is kind of keeping in line with other data processing conventions that are followed by, like I said, SQL or SQL, Spark, things like that. So this is kind of like, Polars encourages a better programming paradigm than Pandas, right? While Pandas treats data frames like objects, right? It facilitates or it encourages object-oriented programming, right? Which is object-oriented programming, why not? But Polars, it treats data frames as the data tables that they are, and that encourages data-oriented programming. Polars has a more user-friendly API that lends itself to cleaner code, right? So with this kind of stuff that we saw before, where we have to have multiple equal signs with Pandas, Pandas is going to force you to break up your query according to its API's limitations. But whereas Polars, right, you could add a dot with columns anytime you want. Gives you 100% flexibility to break up your query where you want to in order to maximize readability, right? So you could do subqueries, you could do CTEs, you could keep, intermittent data frames aside, whatever you want, that makes it as readable as possible. And of course, right, like Pandas does have some features in its API that give it this kind of more data-oriented programming feel. Like it has the .pipe function, it has the .assign function, but they're not really that common in Pandas. But in Polars, .pipe and the Polars counterparts of .pipe and .assign, .pipe and .with columns, they're idiomatic in Polars. They're at the core of the API. And so the next thing to do is to go into a brief demo. But before I do that, let's see if there are any questions. Checking the chat. There are no questions. I suppose I'll ask the audience nonetheless. Anybody have any questions before I move on to the demo? All right. So without further ado, here's the demo. So the demo is a short analysis of Airbnb prices.
Sorry, Ben, it looks like we got a last minute question in the chat. You wanna take that one?
Can I use Polars DF in scikit-learn or stats models? Yeah, you can use it in scikit-learn. I don't know about stats models. I've used it in scikit-learn. I've also used it with XGBoost. That's the best I can give you. I don't know about stats models, but either way, I mean, support is growing. I remember when scikit-learn didn't support Polars. Anyway, okay. Does that answer the question? Cool. So then, without further ado, let's jump to this demo. Right, so here's a link. You can follow it. I'll put it in the chat. It's just from my GitHub. I'll put it in the chat here. But I will show the notebook on my computer here. Cool. So you guys can all see this now. So Polars demo, Airbnb prices data, right? So the purpose of this notebook is to demonstrate the Polars library for data manipulation. And it does so by doing just some basic exploration on a data set of Airbnb prices from Kaggle. So here's the data set, you check it out. The tools used include Polars, NumPy, and Matplotlib, right? So just a basic kind of exploratory data analysis, or EDA as they call it. So we just create the environment, right? Import NumPy, import Polars, import Matplotlib. Oh, I don't think oh, do I want this? I don't need this. Sorry. Great, that runs. Then we load the data. So the data here is, why don't we go ahead and actually look at where the data is, or what the data is, right? It's this US Airbnb open data, Airbnb listings and metrics of regions in the US, right? So some of our columns we have are like an ID, the name of the listing, of the Airbnb listing, the host ID, host name, neighborhood, latitude, longitude, room type, price, right? That's it. So now going back to the demo. Right. So we loaded the libraries, or we imported the libraries. And now step 2, let's load some data, right? But before we load data, let's just narrow the problem. So we choose a target city for our analysis. So which city has the most data, right? So let's look at how the Polars code generated this, right? We did pl.read CSV, right? This is just the CSV file. This is looking similar to Pandas. We do group by, and then we do this .aggregate. And this is where you really start to see the Polars syntax be a little bit different, right? We have this .column syntax where we create where we focus on latitude and we want to look at the count, right? I just want to look at count of each city. So it doesn't really matter which column we use here, it's just a count. So, and then I call it the count column, right, which corresponds to this column. Then the latitude, I want to know the central latitude of each city. right? So just by taking the mean, longitude, same thing. And then we sort by the count descending, right? Because we want to know which city has the most data. And it's New York City, right? Has a very familiar latitude and longitude. And it has, I don't know, I mean, I guess this isn't that surprising, right? The Airbnb, which cities has the most data corresponds to which city also has like the highest, some of the highest population. I don't know the populations of the US cities off the top of my head, but this seems to make sense. New York City and LA are both huge. Anyway, and then you have the same dot head syntax, right? Oh, whoops. And yeah, that's it. So writing that again, why not? So let's just focus on New York City, right? So here we can see the scan CSV doing its stuff, the lazy frame doing its stuff, right? So we have our query here where we just want to load data for New York City, right? So we'll do not read CSV this time, but scan CSV. We're going to filter. We're going to filter stuff where it's only this, where the city is New York City, and we're just interested for this brief analysis. I only care about latitude, longitude, and price, right? Just to keep it simple. And we can do this thing where we select. It's a select, right? It's very similar to the SQL syntax, right? Select pl.call or call for column, and then these three columns. And then I'm going to add another column called log1p, where I'm going to take the log of the price, right? So it's pl.call price, and then .log1p, which is this is common. Well, you'll see why in a minute, why I'm doing this. But anyway, so we create that query, and now let's see what that is exactly. You can see this naive query plan, but before that, actually, right? Polars.lazyFrame. It's a lazy frame. Okay, cool. That's what we wanted. So now it's basically a query. You don't think of it as a data frame. You think of it as a query that could create a data frame when it's ready to. Now, like I said, you guys remember I was saying during this presentation that there's this query optimization engine, right? So if you take this query and you say show graph, what Polars does is it's going to show you what it plans to do to generate this data frame, right? So if I do the non-optimized version, right? Optimized is false, right? So without any query optimization, let's see what it does. Right? This makes sense. So it scans the CSV from my local machine. It selects all of the 18 columns, right? Because if you remember from looking at the Kaggle data set, there's 18 columns, selects all of them, and it doesn't do any sort of filtering because this is a CSV, it can't do that. And then it filters by, once it has it all in memory, it filters where the city is New York City, and it selects these three columns, right? Latitude and longitude and price, and then it creates these columns, right? So that kind of corresponds to exactly what we wrote, right? We scan the CSV, right? That's this. Then we do this filtering on city, that's this. Then we do the selecting, it's this. And then we do this creation of the new column, right? Nice. But now if we show the optimized query plan, it's a little bit different, right? Let me just hide this cell, current output, toggle. Nice. Okay, so now, right, we do the CSV scan, but look, before we were selecting star of 18, right? But here we're only selecting 4 of 18. So Polars has gone ahead and looked and said, okay, to do all this stuff, I'm only going to need city, latitude, longitude, and price, right? So it's only selecting those 4 columns at the moment it's reading it in. So already there's an optimization. And then it's doing basically the same thing, filtering by city, going down to just these columns, and then creating this new column, right? Which is nice. By the way, if this was not a CSV and this was a richer structured data storage format like Parquet, right, which uses Apache Arrow, then you would be able to see a sort of filter happening here, like on this city column, right? This would be actually done upon reading, right? Which is awesome. You know, this it might not be a big deal when you're having this Kaggle data set of like, you know, a couple 100,000 rows, but when you get into multi-millions or even like data sets that are of billions, you know, this stuff can really save you time and save your computer years on its life. I don't know, actually. Anyway, so then we can just create our data frame, right? Where now, what's the type, right? We did our collect statement, and it's a data frame now, right? Great, that's dreams really do come true. So now let's view the data. We can do our df.head like we saw above, right? We have our latitude, longitude, price, and then log of 1 plus price. And now let's just see some different ways of viewing the data. We can do this cool thing with polars where we are going to select all the float columns to view, right? So the price was actually an integer column because I guess they didn't store it any other way. They stored it as an integer rather than as a float, which is nice. And then you can also do this cool thing where you can use regex to select columns. I think Pandas actually supports this too. But anyway, the API makes it more commonly known in polars. I didn't actually know about this in Pandas until I found out about it in polars. But yeah, you can just do this, and it's basically anything that matches this regex pattern. Yeah, will show up in the selection. Is it regex or regex? Leave your comments in the chat. Anyway, the brief, and now, so we've loaded our data, right? We have our data frame. Wonderful. Let's do some brief EDA, right? So we want to see a distribution of prices. You know, we can plug this data frame, the price column, cleanly into matplotlib like anything else. To answer your question, Hare Krishna, I think, yeah, it plugs right into matplotlib at least. I don't know what's happening under the hood, actually. It'd be an interesting question. I don't know if it gets converted to a NumPy array, maybe, by matplotlib, you know, because I know they all have this sort of array-like. Anyway, all that aside. And then we can also do this histogram. And also note that you can select a column as a series, right? See this bracket notation here in polars? This will do a similar thing to Pandas, where it will select a column and create a series. But that's the only thing the bracket notation will do in polars. That's the catch. Anyway, so let's see what this stuff looks like. This is just a distribution of our prices, right? So here's an ECDF, empirical cumulative distribution function of Airbnb prices. It looks crazy, but then if we log the x-axis, it starts to look a bit more normal. You know, no pun intended. The pun is intended. And then if we look at the histogram, right, we can see that of the histogram of the log of 1 plus price, right, it looks like almost a normal distribution in log space. It's still kind of right skewed, but you know, these prices, variables like price and income, anything money related is usually, right, the rich get richer, right? So they're usually heavily right skewed. I guess even after a log transform, it's still right skewed. Anyway, distribution over space. And again, right, we can just pass this stuff directly to matplotlib. We don't have to do any additional transformation. And look at that. You can see Manhattan, kind of. And then you can even see Central Park, right, hanging out there in the middle. And then if I do some correlation, right, you can do the simple dot core, right, similar to Pandas as well, to get the correlation. And this is I mean, latitude and longitude are like somehow correlated weirdly, but I guess it has something to do with the fact that like Manhattan is kind of diagonal, or not diagonal, but you know, Manhattan is like a kind of tends to align. Maybe that's why there's some correlation between latitude and longitude here. Anyway, that's it. So let's go back to our presentation, or rather, let me see if there are any questions before going there. Any questions before I move on? Have you worked with the date manipulation functions in polars, text to date and date sub or date add functions? I have. It's nice. I mean, it's super clean. It's just like, I don't know if you've used BigQuery. I really like the way BigQuery does it, and polars does it similarly. Shaw comments regex. He just wrote regex, like it's kind of a troll. Why not?
Yeah, I'll throw it in there. I did have one question on the example code. So when you made df_query, you made this lazy frame object thing. If we would have done read CSV in that second line instead, that would have just made a data frame directly. It wouldn't have made this like set of steps.
Exactly.
Okay. Yeah, that's cool.
Yes, that speaks back to right, so you see there. That speaks back to what I was saying before. Right here. If I do read CSV, it's going to create a data frame. If I do read Parquet, it'll create a data frame. If I do scan CSV, a lazy frame. Scan Parquet, lazy frame. And so on and so forth.
Yeah, that's awesome. Thanks.
Mm-hmm. Let's go back. Any other questions before we go on? All right, so let's steam ahead. So what next? So I heard about polars, I think first, like, might be like 2 years ago. And I tried to switch, but there wasn't as much support. ChatGPT wasn't there for me at that point, and Stack Overflow certainly wasn't there for me. There's this Udemy course which really helped me a lot. If you're interested, I don't receive any royalties from recommending it. It just helped me. And then yeah, also if you're interested, there's this podcast episode where the author of polars, he talks a lot more deeply about what makes polars faster than pandas, and really gets into like the nitty-gritty details of Rust and C++ and memory allocation. It was a bit over my head, personally, but maybe for you, if you're into that stuff, or if you're coming to data science from a more electrical engineering or software engineering heavy background, maybe it's interesting for you. But yeah, polars is already, it's not so niche. It's not so niche anymore. I think I took this snapshot like a month or two ago. Already polars, I think, has almost as many stars on GitHub as pandas, and it's quickly getting there. So at the peril of sounding too evangelist, join me, come all aboard. Anyway, that's it. So thank you. And if you want, I wrote this presentation kind of as a blog post on Towards Data Science, as Sean mentioned at the beginning, about a couple months ago. If you want to check that out, you're more than welcome to. And if you want to connect, that'd be awesome. On any of these ways below. But yeah, that's it. Thank you for your time.
Awesome. Well, let's give Ben a round of applause for an awesome presentation. We're going to move into a Q&A session, so feel free to drop questions in the comments section, or go ahead and raise your hand. Looks like Tan has his hand raised, so yeah, go ahead, Tan.
Hey, great presentation, Ben. So, I'm coming from a, I guess, software development and, marketing perspective, and I actually did switch because of ChatGPT, so I thought that was funny that you mentioned that. So for me, would you recommend like the Udemy course as like the best route to like really get my feet planted in this? Because, I did one project in polars already, and I got a little bit of a feel for it, but I just don't really know what else it can offer besides, solving a specific problem that I had.
Yeah, it's a good question. I'm not going to be one to, we all have our own learning paths. I know some people love to just dig into the weeds of some libraries API. Some people like Udemy courses. Some people like YouTube videos. I wouldn't prescribe something. The Udemy course gave a nice tour of all of the functionality of polars, which was super nice. I mean, just for example, like this regex thing, which I mentioned, I saw about it in the Polars Udemy course, and then I was like, huh, I wonder if Pandas has something like this. And it did. And I never knew it. I've used Pandas for like, I don't know, 6-7 years longer. And I never knew about that. So yeah, there's definitely pluses and minuses to the different approaches to learning. But yeah, that Udemy course worked for me. I recommend it. But I more just recommend you learn in whatever way you think works for you the best.
All right, awesome. Appreciate it.
So we got one question in the. Oh, go ahead, Ben. Sorry.
No, yeah, I was just gonna say there's one question in the chat.
Yeah, we got it from Harry. I'll go ahead and read it for everyone. From a computational perspective, if I don't use a specific column in my query, does Polars not call it to memory at all while running, like how it works on BigQuery?
Good question. I think that's correct. If I don't use a specific column in my query, does Polars not call it to memory at all while running, like how it works on BigQuery? It shouldn't. It shouldn't. The only thing I can think of, I mean, the only time where I can think it would, because even with the CSV, I mean, the CSV is like the lowest structure, or the lowest complexity, or how would I say, the least structured or the least richly structured data storage format that's out there. And even I know when Polars reads a CSV, it even like reads the top few rows, right? To see like, oh, what are the data types? What are the column names? And then it reads the whole thing in. So even with CSV, I think that it should know. And that's what we saw, right? That's what I mean, empirically, to answer your question, empirically, that's what I've seen. If I don't use a specific column in my query, then Polars will not call it into memory at all, right? That's empirically what I've seen, but from looking at the optimized query plans. But you know, if you experiment with it and you find something else out, definitely I'd be curious to know. So, but by design, also, it does not call it into memory.
Do we have any other audience questions? Oh, we got one from Harry. Go ahead, Harry.
Yeah, I had a question regarding how Polars basically determines the data types while it's reading data into memory. So when it comes to libraries like data.table in R, it basically looks at just the first row in the CSV and then accordingly assigns those data types to the rest of the readable data that is present in the CSV. Does Polar do the same thing? Because I've faced few problems when the CSV is corrupted or anything of that sort. So just wanted to see if you had any insights on that.
Yeah, it does do that. I think it reads not just the first row. I think it reads a couple rows. But if I recall, and I'll have to, I can check on it and get back to you, or you can check on it and get back to me. But if I recall, you can control these things in numerous ways. I think you can pass a schema to the read operation, I think, or the scan operation. And you can also, I think you can also control, like, only infer the data types after reading the whole thing. I think you can control that. I'm not sure exactly. I'm curious. We can go check. But anyway, yeah, I'm not exactly sure. I think you can control it.
Yeah, it's a good question. So Any other questions? I have a couple of my own, but I want to make sure everyone else has the opportunity to go. Yeah, go ahead, Tan.
Yeah, so I guess just related to my last question is, if you had to learn this again, like, you know, just like from the start, what do you think you would do differently?
If I had to learn polars again from the start, what would I do differently?
Yeah. Like, what do you
Um,
like? What are some lessons you kind of learned along the way that you wish you had known from the start?
um, I think I would have taken the Udemy course sooner, because I mean, I saw the potential of polars. You know, it was obviously awesome from, I mean, a friend introduced it to me who's, you know, super sharp, and he's like you know, studied computer science, and he was like, yeah, Rust is awesome, da da da. And so you know, that's where I first heard about it, and I was like, oh, this is great. But like, being an early adopter is always painful. And so I just, yeah, like I said, it was tough. I think as soon as I saw there was a Udemy course, I should have done it. I would have just done it faster. I would have switched faster. It's like I feel like I really stepped into the light. So yeah, I would have just done the Udemy course sooner. But I don't know. I'm not that, pretty content with the way things went.
I feel that transitions nicely into my question, because I'm kind of curious, and I think one person on LinkedIn actually had this question as well. But what did your transition look like? You know, yeah, I'm sure it was a bit a little uncomfortable, because you know, all the muscle memory from using Pandas and the familiarity. What did that transition look like? What was the time scale? How did you just kind of cold turkey, like, okay, all my projects at work, I'm going to start using polars, or yeah?
Well, first thing, I was actually looking, um, I was looking here at the scan CSV. Harry, I was looking at the scan CSV function. You can see here what it does is there's two things. You can either pass the D types like a schema, you can pass it directly to the scan CSV operation, or there's this argument infer schema length, right, which is the maximum number of lines to read to infer the schema. If it's set to 0, then all columns will be read as a string. If it's set to none, a full table scan will be done, right? So you can control, yeah, you can control it. Anyway, that is aside. I thought you can control it. Sorry guys for that brief aside. It's called. So, okay, Shaw, your question was, I'm sorry, can you please repeat it?
Yeah, for sure. Just basically what your transition from Pandas to polars look like.
Right. Yeah. I think maybe serendipitously I was changing teams at work, or changing projects. And so I didn't really have any production code that was depending on Pandas at the time. I didn't have any notebooks or something I was still working on at the time that were in Pandas. So I happened to like have a crossover in my work right around, and also that was when I started like building a system on a freelance project, was was around the same time. And so it was in that transition phase where I just happened to be like learning polars. So I think serendipitously, I didn't have to do any sort of major refactoring or migration of code or something. Um, um, but, but yeah, I mean, but besides that, yeah, I mean, after that time period, like I never wrote Pandas again. I think the only thing I use Pandas for is actually displaying data frames, which is still really nice. Like if you want to stylize a data frame and, you know, write it to some HTML or to some image, I still, you know, Polars doesn't have anything like that. But you can always, you can switch between Polars and Pandas super easily. So what I'll usually do is I'll just like do all my coding, do all my stuff in polars, and then all my operations and research in polars, and then when it's time to like show it to some stakeholder, it's time to like put some data in a table and like in a report or an HTML file, then I'll do like .to pandas, and then I'll just do the whole like pandas style thing from there.
Okay, that's cool. So just you just started a fresh new project in polars, and that was kind of the transition.
Exactly.
Okay, yeah, that seems like a good way to do it. So we're getting near the end here, but I did want to give one last opportunity. If anyone had any questions, just go ahead and raise your hand or drop it in the chat. Yeah, go ahead, Tan.
So this isn't really related to the presentation as much, but I was just wondering, do you have anything that you're like planning to work on next with pandas that you think would be interesting to mention? Like, obviously, there's some stuff you can't mention if it's related to work, but is there anything that you're like eyeing with pandas that you kind of are interested to work on?
When you say that I'm eyeing with pandas, do you mean eyeing with polars?
Yes. That would be.
Yes and no. I mean, I'm eyeing all the same data science work I would have otherwise. I mean, this is really like, this isn't like some tool that's doing something for me that I couldn't otherwise do before. Yeah, polars has mostly just replaced all the things I was using pandas for, except this like stylizing tables, which I just mentioned. So yeah, there's nothing new I want to do. It's all the same things. I just now using this new tool.
Awesome. Well, let's thank Ben once again for an awesome presentation. I learned a whole lot. I got a lot of notes on my end here. We're going to share the event recording in our Discord in the past events channel. We'll share the link and a bunch of other resources related to the talk and how you can contact Ben and keep up with his stuff. It'll also be uploaded to our YouTube channel. If you're not subscribed, go ahead and do that. It's just the Data Entrepreneurs on YouTube. We also have a post-event survey. So if you have 30 seconds after this, give us some feedback. Give some feedback to Ben. I'm sure he'd really appreciate it. And with that, thank you all for joining on a Sunday morning. And thanks again, Ben, for an awesome presentation.
Thanks, guys. Really appreciate it. And thanks for all the questions. And yeah, look forward to seeing you guys around.
Yeah. Thanks, everyone. Take care.